The Ambient Intelligence project at MERL combines novel sensor network platforms and perceptual technologies with work on visualization and interaction. Here we see streaming data from a sensor network at MERL. As someone walks down the hallway, they leave a signature in the data stream. This visualization shows the person walking down the hallway, while the motion of other people is also evident. Visualizations such as these help the user find interesting patterns in the data, such as on this day when there was a fire evacuation. Here we can see the people streaming out of the building in response to an alarm. The table modality allows us to directly manipulate maps and other data, and allows us to use gestures to search the data in an intuitive way. These technologies combine to form a powerful search tool. A gesture is used to specify a spatiotemporal pattern to be searched in the data. This pattern happens to correspond to people collecting a soda from the machine and walking to the front door. The search results include a video of people who match this pattern, people carrying soda bottles. Building-wide systems require building-wide awareness. Sensor networks provide an economical solution. Low-power wireless sensor nodes can move data without wires, thus reducing installation cost. Information is collected by base nodes and passed to building services. Sensor networks reveal building-wide patterns. In this visualization, we see sensors on the vertical axis against time on the horizontal axis. As we zoom into Tuesday afternoon, we can see people ending their workday as the building becomes sparsely populated. As we zoom into the data even further, we can see the fine structure of human activity as people walk around the building and have meetings. Zooming back out, we see the structure of days and nights, and eventually weekdays and weekends. We can also explore usage patterns of the space, in this case a lecture hall located in the upper left of the map. Because the lecture hall is only used several hours a week, it is represented by a white line on the timeline, with blue dots for the meetings. In this example, we explore the work habits in the building. We can see that this wing of the building is occupied from 9 to 5 every day. This creates a notch in the visualization, seen here, because the rest of the space is utilized much more heavily, up to 18 hours a day. Combining sensor networks with camera networks can be very powerful. In this example, we see how sensor networks can help us automatically generate video summaries. The user specifies a spatiotemporal query. The results from that query index into a video database. A video summary is assembled from that database. This is possible because the system understands the relationship between the sensors and the cameras. This relationship can be learned automatically. We can improve the effectiveness of these systems by including higher-level models of human behavior. A tracklet abstracts away the individual motion activations into a higher-level model. This abstraction allows us to reason over longer spans of time and larger spans of space. Ambiguities in the data are represented as junctions, which knit the individual tracklets into a graph as a complete explanation of the data. Here we see the raw motion activations displayed in the interface. Once they are overlaid with the tracklet graphs, we can see the begins, the ends, and the ambiguities. In this example, we use the tracklets to refine our searches. Let's search for an individual by asking the system to find us the beginning of a tracklet. The result is a tracklet representing someone leaving their office. At this point, there's an ambiguity that must be resolved. The system presents the available video and motion evidence, and the user makes a decision. Once the ambiguity is resolved, the user walks the rest of the graph to generate a complete description of the activity. The description will include the motion traces and all the video evidence that the system has. Here we play back the story of someone's coffee break. The comprehensive motion data from the sensor network is displayed on the map on the right. It gives meaning to the limited video data by placing it in the context of larger activity.